All right, Kaya, and welcome everybody to the last seminar of the series for this year. And I start by acknowledging that we're presenting this seminar here from Murujuga country, traditional country, and pay my respect to the traditional owners, past and present. Okay, so as I said, this is really the last seminar this year, if I manage to move slide, because that's usually what's happening after that. Yes, apparently we might be moving to Wednesday, 2 to 3 p.m. next year. So just keep an eye out on all of the social media for updates about that. And we already have a talk for the start of next year. Yes, so yeah, around end of February, March, I guess. And Emily and India will probably be starting to take charge of this. So, and then we have a range of other talks actually that are already in line, so that should be cool. Reminder that this is being recorded. If there is authorization, we'll share it on the YouTube channel as well. Same thing for the people online. When you're sending your questions and the chat, etc., all of that is recorded. And now I can introduce Patrick, who's a PhD candidate here at UWA, and he's going to give us his research proposal for his PhD that he recently started under the Dating Murujuga Dreaming Linkage Project. And Patrick also was a student at UWA before, did his bachelor in archaeology here, and also a graduate certificate also at the University of Queensland. Oh yes, yeah. In biostatistics, yeah. And then he also worked at the Western Australian Museum as an assistant curator for a year before starting the PhD here. So over to you, and I'm going to stop sharing this so that we can see your PowerPoint. Okay, now other sharing, come on. Why is it not happening anymore? Yeah, I can't. Oh, it's here. Oh, okay. Here you go. Yes. And we're going to make this really small. Yep. Okay.
Nice. Thank you very much. Thank you all so much for coming. It's nice to see so many people here. I'm just going to be talking a little about my proposal for my PhD project over the next few years. And this is the title. I'm going to be looking at Murujuga and studying the Holocene climate. I'm in the context of island use and, like, in particular, maritime island use. So how people are using the islands, how people are getting between them, why they're going out there. Before I start, I'd like to acknowledge that we're in Murujuga country, and because we're talking about climate today, I've also put up all the seasons that are here. And obviously the seasons are very different in Murujuga, they're different down here. It's nice to think about and make sure that knowledge is acknowledged. More broadly, I'd like to acknowledge all of the people that are involved in this project. This project sits within the Dating Murujuga's project, Dating Murujuga's Dreaming project. So there's a lot of people who are going in and organising a lot of things, making a lot of the fieldwork happen, and a lot of people I'm going to be working with over the next few years. And a lot of organisations going into funding that, so I'd like to thank all of those. What is this talk? I'm going to be doing my PhD over the next 3 years. I started in July. This is a 6-month milestone where I talk about what my project is going to develop into over the next little while. The written version is to be submitted next week or sometime soon. But this is what I'll be talking about today. I'll talk about Murujuga. Most of you are familiar, but we'll run down where that is and why it's important. Talk about the big picture ideas and why we tackle them through, like, this maritime and climate lens. And these big questions in archaeology, the questions of scale and humanity. Then we're going to talk about the methods I propose to tackle these questions and the ones that I want to develop, how that relates to all the papers that I'm hoping to publish, that will form the thesis chapters, a bit of admin that I have to do, and then relate it back to some broader significance about where we go from here as humanity. So my main project aim that I want to get in everyone's head is that we'd like to move towards human-scale climate reconstructions in the deep past. So we know Murujuga is a place where climate is very important to how people react and to how people respond to these islands. So we'd like to zero in on that in this context of maritime use of islands.
Keep going.
Perfect, thank you. So, step 1, Murujuga. Murujuga is a place that has been studied and researched in this context of human and climate interaction. So people have been living in Murujuga, which is on the northwest shelf of Australia, in the Pilbara region for over 50,000 years. And over that time, they've been obviously living there, eating there, and creating art there. This is an incredibly important place worldwide because there's almost 2 million or over 2 million lovely pieces of rock art, which is more art than almost anywhere else in the world. And it's currently 42 islands and the Barrow Peninsula, but it hasn't always been that. So here's the Northwest Shelf, just here. We've got Barrow Island, all of the other Pilbara Islands, and then Murujuga, which is sticking out there. But as I said, and a lot of you seen this already, this is some common with this visualization, but like most islands, or pretty much all islands, it hasn't always been an island. It used to be really quite far in the mainland, about 160 kilometers during the last ice age. And as the sea came in, as the ice age ended, or the water and the ice caps melted and fell into the ocean, the place dramatically changed. And we've modeled how people have responded to that. So it's significant because you can see the change in the art. It moves from this terrestrial repertoire of like kangaroos and lizards and emus to this clear marine signal. And you've also got these other interesting responses. So people are changing their mobility patterns by creating like more sedentary lifestyles. And that's shown through some of the earliest house structures in Australia. And you've also got these interesting things happening through the Holocene. Somewhere in the mid-Holocene, there's a change between using like mangrove shellfish and moving towards these more like sand flat species. There's a change in the economy as a response to something that's going on. It might be the sea levels are disrupting the mangroves and it's collapse. But that's something that everyone is still working through. And then moving all the way to European contact, there is some evidence of people using these islands. When Dampier first went there in 1699, he didn't see anyone out on the islands. It's interesting he was there during summer or winter. But Philip Barker King did, and this is something that was drawn at that time. It's a young warrior man on a log, traveling between the different islands, and he observed people, many people using the inner islands and visiting them, and then also some evidence, some fresh tracks and some fires on the outer islands indicating people were probably out there now. And that's also reflected in a lot of the archaeology. It's relatively clear that people are visiting these islands throughout the Holocene, at least in some way, even if that's different to how they were using them when they were part of the mainland. A really interesting thing to pick up on here is this, like, in terms of climate, this element of seasonality. It might be significant that they were spotted out on these islands during summer when there's the monsoon and there's water availability on the islands, possibly because there'll be rain and that might recharge the water holes. And then it will also increase the amount of turtles nesting. It's a very different environment during the wet season than it is during the dry. There are a lot of places in Australia where island use and coastal use is highly seasonal. So this is something that will be really interesting to start thinking about all the way through the Holocene. Can we resolve this seasonal use? Okay, with all that in mind and knowing that Murujuga is a very special place and a place where we study climate and human interactions with that, I'd like to zoom out and think about these like big pictures in archaeology. Archaeology has always been concerned with like this question of scale. We've got this enormous archaeological record, and we also are trying to find individual human events. This being Mike brought up in Reed a little while ago. I remember doing it undergrad. This is one of the most incomprehensible diagrams I've ever seen, but it shows how hard it is to think about these archaeological problems. And you've got these like big societal changes, ones that archaeologists are rightfully very skeptical of. These questions in Australian archaeology, this idea of intensification, which has so many exceptions, and people will argue about that for as long. And the question of agriculture, this like global trend towards agriculture, as we've been discussing, especially in the last few months, is one that is not a simple pattern, as much as we'd like to model it to be. Because archaeology is built up of all of these much finer patterns. It's built out of exceptions, it's built out of moments of seasonality in particular. For some of you who've read stuff about David Rader and David Wingrow's book coming out, kind of points to that being interesting, but also the record is made up of tool discard, it's made up of art production events, it's made up of things that happen in the moment or at the very least on like a monthly or yearly timescale. But it's interacting with these cultural changes that we can see happen over tens of thousands of years. Are these coherent? I don't know, but that's clearly something archaeologists are thinking about. What I find interesting as well is that we're relating it to these enormous patterns in the Earth system itself. So here's like a broad overview of the Australian climate and some of the big features we've got. these are operating not on a human scale, they're operating on a planetary scale. You've got big processes like ENSO, which we're probably going into a La Nina now, and that changes the way that our lives will be for a little while because we're still flying. But also the Australian monsoon is something that happens seasonally and massively defines the way people live in the north, even though it only impacts people normally for like a month or two a year. And then you've got the other big atmospheric phenomenon. The ITCZ is like something that happens along the equator. That doesn't impact anyone directly, right? It's an atmospheric phenomenon, but it changes the way that like ENSO, its position changes the way ENSO or the monsoon behave, and that does impact people. So people who work in climate have thought about these problems, and just as we have these interesting conceptual issues of scale in culture, it's also true in kind of most sciences, but especially climate. This is an idea that I find really interesting, Sean Lovejoy's idea of macro weather. So the idea is that there are separate units of things going on in the climate. There's not just like small little things happening in a weather scale moving all the way continuously up to a climate scale. There's these like different sets of phenomena happening. One of those being weather that exists on this like 7 to 10 day scale, where you can predict the weather, you can define it, and we're all pretty happy with knowing what the weather will be happy. Then you've also got these enormous processes, things like ice ages that exist up to about 80,000 years. They're really big changes. But I'd argue that people are really responding to this thing Sean Lovejoy calls macro weather. And this sits in between the scale of weather and climate and seems to exist on like a 50 to 70 year scale. And the reason he argues that that is a thing that exists is because when you look at the differences in the way that the climate operates, there's enormous changes on this like weather scale, right? If the today is 5 degrees hotter than yesterday, that's not much of a surprise, that's actually quite normal. And if an ice age is 4 degrees or 6 degrees, 6.1 degrees, like colder than today, that's also not much of a surprise. But if you take these like 50 to 70 year averages, you see an enormous reduction in the amount, and you can see it here, it goes down to like 1 or 2 degree variation. And so he makes the argument that macro weather rather than climate is what you expect. And so I would say that if humans are interacting with the environment, which of course they are, it confines and makes like the things that you do worth it, then people are responding to these like 50, 70 year averages, these generational phenomena in wind patterns, in rain, in seasonality. I think no one becomes like a sailor and builds a like sailing technology and culture if there's one like windy day, right? But people will start building these cultures if that's something that exists over a multi-year timescale. So that's, again, an interesting thing to think about, and we'll come back to that as we talk about methods. But lastly, I want to touch on this idea of maritime behavior. So why, if we're dealing with all these really tricky and ideas about the scaling culture and how they will build up to these ground changes, and also the climate and how this is operating over multiple scales, would we go with maritime behavior? Maritime behavior is something that has been thought a lot about in the context of like human modernity or symbolic behavior. These are really tricky ideas, and we're still not exactly sure what a modern human is, but we do know that people are capable of enormous ocean voyages. One of the most impressive and earliest ones is the one from like Sunda to Sahul, where people crossed through Malaysia for at least a few days, probably following the monsoon, because you couldn't have done it randomly. It was probably up to 1,000 people or over 1,000 people, and they have to have done it in some way intentionally. One of the best ways to do that is to make use of those seasonal patterns. But this sort of behavior involves like a complex hafting. You have to be able to make quite advanced technology. You also have to have some level of language and information exchange. You have to be able to give things meaning that they don't have and communicate those meanings between people to build up these maritime cultures. And this is demonstrated all the way along the southern arc route, all the way down to Barrow Island, where people are still using the coast when they arrive. But it's interesting, and that's why that like island use is really used as this like way of testing humanity and how they respond to climate. In general, then, when you get to the Holocene and the current set of islands, people have reviewed how they are in Australia. It's very clear, whatever it is, that it's different than the colonising repertoire. It's different than what people came from Sunda onto this continent. It adapted over that enormous period of time. That's no surprise. These are from NALA's 1995 review of islands in Australia. And one theory and one model that she explored is that there's this general pattern of intensification before separation. So as it becomes the coast, there's intensification. As it gets cut off, people abandon these islands, and then people slowly come back to them during the Holocene, and people are visiting them as they like develop more maritime culture, or it becomes integrated into the maritime economy. There are an enormous amount of exceptions to that now, and that model certainly doesn't hold true for all islands. But it's interesting that there are still very many islands that this model does hold true. And Murujuga and the outer islands being pretty close to one of them, there's certainly a change in the people interact with the island when it intensifies as a part of the coast, and then there is a cut-off and people are using it. They're not going into the middles as much, they're using it much less intensely. But in terms of thinking about islands, there are three different ways you can look at them archaeologically. There are like islands that are representative of the old mainland. So they're islands now, but that's not what they are archaeologically. Like Barrow Island being one of the early stages, is it's a coast, but people don't see that as an island because it's not at the time when they're living. But then there's also these islands that were abandoned. The population went extinct. So there's a few of these in the Bass Strait or like Kangaroo Island of South Australia. And then there's also islands that were visited through the Holocene. This is going to be more true in the islands in the Bass Strait, but this is certainly where Murujuga falls. It was cut off, people changed the way they interact with them, but they're still getting there with watercraft. The other super interesting thing is this is important in the southwest, which is often being modelled as a place where people aren't crossing to islands in the Holocene. This is seen to be a difference between the north and the south. Now, this isn't entirely true. There's records, and I've got some pictures later in Tyndale's work, which shows that people do have rafts, and there are numerous stories of people visiting islands in the southwest, people visiting research. So people are visiting a lot of islands, and probably more than we think, as more ethnography is done. But there certainly is some interesting pattern around Australia. There is some odd difference between kind of the west coast there and the north, and that's something that I'd like to kind of poke a little bit and investigate as my thesis goes on. And so this brings back to that thing I mentioned before, which is that islands then, because of their complex use and because of how dominated they are by these climate phenomena, they're a really good test bed for how people react to the climate and how it constrains behaviour and how people respond to that. You've got local extinction and abandonment of places like Kangaroo Island, but then it's also linked to other phenomena like changes in ENSO. So this is said about islands in the Southern Great Barrier Reef. It's said about islands like Vanderbilt Island in the Gulf of Carpentaria. The idea being that as ENSO frequency increased or intensity increased about 1.3 thousand years ago, people stopped visiting those islands as much because maybe there were more storm events. But this is an interesting thing where, going back to that idea of macro weather, people aren't responding to these big climate changes. They are responding to those like days of bad weather. How many days of bad weather do we have? So that's something we have to start. That's the scale we have to get to before we are to test those theories. And as mentioned before, Murujuga is also a test bed for how people respond to climate, and it's in part because it's islandized. And you've also got this idea of seasonal access to the island, which I mentioned before, but that's also been thought about in the Kimberley. So O'Connor's work saying that people were accessing these islands year round, but that's not true in the south, where there's more seasonally reliable patterns of seal, what is it, nesting? No, they breed. And seabird nesting is what I'm thinking of in the south, that people are going out seasonally to these islands rather than visiting them all the way around. So is this something that is driving the difference between like northern island use and southern island use? There's some of the rafts that I was talking about in Tyndale's book. So with all of that theory and those kind of big question ideas out of the way, this is the particular aim of my project. I'd like to review the geography of islands in Australia and how that's changed over deep time to kind of start pulling out some of these theories on like how this climate change affected them and how like the different amounts of islands in different places could have influenced how culture developed. There's already some excellent reviews on this work, and there's a lot of work that's been done. I think where I can contribute there is there's been extra work done since then, and there's also a greater understanding of climate. And we'll also start looking at islands under the sea, which I'll talk about in a moment. I'd like to then secondly understand in particular the islandization of Murujuga. So again, zooming in and understanding this in a much greater detail, so we can really start tying out these like individual adaptations, these individual responses, rather than these really, really broad stories that you get on a continental scale over thousands of years. And And then most importantly, I want to reconstruct the climate of Murujuga on a human scale. So here I'm talking about mainly the atmospheric climate, so trying to get to those things like ENSO and the monsoon, and wind patterns in particular. Wave climate is another consideration that will be very important. But Sue Connor made the argument when talking about the Kimberley is that people are moving between these islands on relatively simple craft through pretty tough island bodies of water to navigate. So I think that probably if people have like cultural and economic reasons to visit the islands in Murujuga, they're probably going to find a way to do that. That being said, we have the rest of the project working on these ideas of, well, then what does that look like? What do the tidal regimes of the wind climate also contribute to this story? How hard is it to voyage between islands? I'll only touch on that from like a wind field perspective. So the key aim out of all of that is to really develop that methodology of, well, how do you understand human responses to climate in the past? And to do that, how do you reconstruct the climate itself on that human scale that matches that archaeological record? All right, I'm going to take a drink of water to talk about methods. In order to reach those aims, I've got a few methods, but one that I will build to sticks out the most, which is really this idea of data assimilation. Before I get to that, I'd like to again mention there's been a lot of work done, so a huge part of the front end of this project will be like desktop work in reviewing all of that literature and seeing where Murujuga might fit into these broader trends. This is obviously something that's been done, you don't want to go over old work, and this is a project within itself. But added to that, I think it would be really interesting to do this like GIS assessment of islands under the sea. So this is something that has been done in looking at the patterns through the glacier, how people move from Sunda to Sahul. And that there are a lot of islands that don't exist anymore but used to, and they will have impacted the routes that people have taken. I think this is also broadly true, and this is something the supervisors have been discussing, of Australia. And there are different places, for example, the Kimberley, that have always been like highly islandized. There's heaps of islands there. And there has been, at the height of the OGM, all the way through to the Lake Holocene. In other places though, particularly like the southwest, and you notice in Murujuga, the Pilbara coast is a lot simpler at those lower sea stands, and there's a lot less islands. So we're toying with this idea of, in places that you have this extraordinarily long period of islands and people responding to those and people living in them, is that different to a place that has been really recently islandized in the Holocene, which is places like Murujuga and places like Archaeology. And it is interesting to think there might be some sort of technological difference you see between there, or some sort of cultural difference. People might be interacting with those environments in a different way. And that's something I think we can start teasing out with those big GIS assessments in the context of the rest of the work that's been done, because we know from everything that there is also not going to be any simple continental trends, and people will do whatever they want. But at the same time, there's probably got to be something, otherwise as archaeologists we don't have jobs. So then lastly, I'd like to really review that archaeology of Murujuga. This is an area that I've worked in now for a good few years, but there's so much work that has been done and so much work that is currently being done. It will be a lot to make sure all of that work is carefully considered. But my focus will be in particular on that like Holocene and islandization, which is already a big focus, but I'd like to really tease that out and work through it. My second big thing that I will have to look at is climate proxies. So these are the way we understand past climates. We find little bits of evidence from the past and can use them to infer things about the climate state. So from coral records, you can get sea surface temperature. You can use things like here, tree rings can also just tell you a particular thing, but then we can work on understanding more of the questions about the climate. There are already a bunch of reviews and a bunch of databases, so part of this work will be pulling those together, but then there are also obviously some proxies that aren't in those like databases easy to access, and part of that will be finding those appropriate ones all the way to the Holocene. This is a really good example of a paper. This came out, I think, like last week, and it's a collection of proxies to understand the Queensland climate and how like the water availability that currently could be impacted by climate change and how we plan for that. That focuses only on the last 2,000 years, but is nonetheless a really, really good source of information. And they importantly use this like linked paleo data format to keep everything very open. This is an emerging standard. So part of the work will be making sure that all of the data we collect and the things we can build on what other people have done through using these standard formats and softwares. But also people can easily build on that, whether it's our team in the future or just other people looking at similar questions. The other thing is not all of the proxies that we definitely need might exist, or we're pretty certain of that. But there'll be, even though we can start pulling in information like they did from like Vietnam still informs the climate of Queensland. You still, the more specific you can get, especially when you're looking at the human scale, is important. So one of these things we've been developing in some of our recent fieldwork is some particular proxies for what we're interested in. So this is Henderby Island, one of the islands kind of in the middle of the archipelago. It's definitely quite a voyage to get across. And there's this huge north-facing dune that's being mapped out there. And the interesting thing is, during the middle of the Holocene, the sea level fell slightly, came to icestand and fell down. And that's what we think we can see all along this dune, is that as the sea level has dropped, the dune's degraded, and it's captured these like particular shorelines from different times all the way along that dune. What's interesting about the dune is that it would have to have some sort of like northerly energy or something to form it. It probably couldn't have formed under what we see today. And it could have been a bunch of things. It could have been deep water swell, which you can see in this picture. Not too well, but you can kind of see the lines here. Is that there is swell building up slowly there. But also it could have been prevailing northerly winds. It could have been an increase in cyclone activities, like the one that you can see pushing northerly winds here in 2017. We don't know if that's something we're working through, but what we did is see me digging into the dune there to look at the beach underneath, to get some OSL dates and some radiocarbon dates on that to like date the last position of that beach, which will hopefully tell us when this dune formed, and then give us a clue about, well, what are those winds doing, what's the swell doing, and we can use that to then move forward and interpret synoptic patterns during the Holocene. Then that brings me to like my most important method and the thing that I'm going to be really working towards through this thesis, which is data assimilation. So the idea of data assimilation is that we have like proxies, which are data, but they are not like perfect representations of the world, as no data is. And data assimilation is simply the practice of combining those measurements with existing models about how we think the system could have worked. In this case, it's climate models that are normally developed for like IPCC assessments or other forecasting climate change. Those have really important information, but aren't informed by like actually what happened, the evidence that we have. They're built with that in mind, but not in particular when they're run. And proxy data, again, is an important record, but it doesn't capture this entirely spatially complete field. It can't tell you what the atmosphere is doing. Only by combining those pieces of information together can you do that. So how do you do that? This is an example that Ian Goodwin put together on my supervisors in 2014, looking at Polynesia. One of the important things there is the wind fields. If you're going to sail between islands, you can't do that again, like purely against the wind. It just really doesn't work. What you need is either downwind or offwind sailing. And what they were able to demonstrate by getting about 30 proxies of all of these different types of things, so tree rings, ice cores, corals, speleothems, and caves, were able to reconstruct the sea level pressure at the time by informing a model, I think the CSIRO climate systems model, with those pieces of data. And if you can get the sea level pressure, then you can, like, wind flows down those gradients and you end up reconstructing these wind fields. This is not something you could pull directly out of a speleothem or a tree ring or an ice core. It just wouldn't tell you that information. But with just like 30 proxies in this case, they were able to demonstrate that at some times it was a simple downwind sail to places like New Zealand from the rest of Polynesia. And that was like an important finding. The way that they use that is the best matching analog approach, which is one way of doing data assimilation, where you just figure out like which of the ensemble runs, you run the model like hundreds of times, and figure out which one matches your data better. But there are other ways of doing that, and there's been a flurry of recent papers in data assimilation. This is a recent one trying to constrain that like ice age temperature, the LGM temperature, showing that it's 6.1 degrees below average, below what it is now. You can see all of the different proxies that they have as little dots on the map, and then the output, which are these spatially complete fields that show you what the whole atmosphere was probably doing, or at least the best guess. And I like this figure because you can see here is what the model spits out, these climate models, which has a lot of uncertainty, but certainly gets you somewhere. And then here is what the data would suggest. But again, like all data, it's full of biases. These are like going to be marine or in particular places will only come into being in particular environments. By combining those, you get like a principally consistent estimate of whatever is in the middle of those things. And you can see that it does really squish in, and it does tell you more specifically what the climate is. In this case, the data would have been very far on the high end of what you actually is consistent with the physical processes in the atmosphere. Another example, which we published this morning, is this reconstruction from the LGM all the way to the Holocene. I have the preprint, I'm not that quick. Yeah, so one of the interesting things in the climate was this idea that there is a Holocene warm period before it cooled down again. And this is one of the few papers out this year that show that that's probably not a real phenomenon. And it does the same thing. You can see that the different runs of the model combined with all of the proxies gives you, again, this complete time series and this complete field of what the atmosphere is doing and what the temperature is all around the world. So you can just take a simple average of that. But it also importantly gives you this uncertainty that is built in. Uncertainty in climate work is obviously really, really hard to deal with. It's hard to deal with in every field. And the strength of this approach, and this is the Kalman filtered approach, is that it does also output uncertainty. It doesn't just give you that simple point estimate of this is what the wind was or this is what the temperature was. If you put in terrible data and your model cannot figure out what's going on, it will tell you that pretty quickly, as long as you treat it safely. And that's important information because it's entirely possible that we simply don't have the data, or we don't have the ability to reconstruct climates in everywhere on this human scale. In fact, that's almost definite. But knowing that precisely and where more data is needed is also a really important piece of information. The third example of this, which is in 2018, is a similar approach. It's a common filtered approach, but it deals with the hydroclimate. So this specifically models like where the IPCZ is, and it includes the metrics about ENSO. So it can tell you specifically like when La Nina or El Nino is likely to happen. And it also interestingly deals with seasonality, which we talked about earlier, being really important for humans and something that you have to deal with on the human scale. As you can see, they did like a June through August and a December through February one to capture like differences in monsoon behavior. And so this is again something that is really hard to do in any other way. So all of that is information that, as an archaeologist, I don't know very well yet. I've been working through over the last few months trying to get my head around what are those big climate drivers and how do you interpret all of this data. But I'm lucky to be working with climate scientists, in particular Ian Goodwin, to develop those skills. And one of the important things that I'd like to bring to this is, obviously as social sciences, we are always interpreting scientific data. But we're interpreting these things through a human lens. We understand the like sheer complexity. We understand that like humans will do whatever they want. And we understand that people just won't just notice one climate and spontaneously react in a way that we could always expect everywhere. And why I think it's important for social sciences like me, scientists like me, to train up in these things, to properly understand how you deal with that numerical uncertainty, you deal with those climate systems, but also be coming to it from that human perspective. Obviously, I'm not going to be the best climate modeler in the world. We've got those, and it's important to work with them. But I also hope that by training up in those things, it's something that like I can come with a human-first perspective to it, and it will end up with a really interesting result. So, practically, what will this hopefully end up looking like? The first two papers are designed to be very like desktop and review focused. So this first paper I'd like to work on is, again, this review of Australian archipelagos and how it's changed through deep time. Again, this has been attempted many times before, but it may well be time again. What I think I can particularly bring to it is this particular understanding about the climate and how that might have affected it. That's mentioned in a lot of these papers, but it would be nice to come to that from like an explicitly climate science perspective, but also this like GIS contribution of understanding islands under the sea and how those changes through time, Murujuga being a recent island, and in comparison to some of the other ones, could be an interesting contribution. So I'll have to do that sort of review anyway, because to understand Murujuga and understand climate change, I've already demonstrated I have to prove I understand how people interact with islands and how people use islands in Australia. But I think we can, that being said, turn into the first interesting output that other people can read and build Second, I'd like to understand particularly Murujuga in the Holocene. So this would be like the second paper working through this like Murujuga Holocene record, and particularly there's like that moment of ionization and the things that follow that. We've got a lot of new bathymetry, which can give us a better insight into the timing of ionization and the crystal processes that go into that. And there's a whole bunch of new archaeological work that's been done and is still being published that lends interesting new information to that. So it'll be nice to go through, review that, and start building some like explicit models about how that would have worked in that moment. Taking all the lessons we've learned from understanding Australian archipelagos. But then lastly, the kind of big paper at the end is this moving towards this climate windows in Murujuga. So trying to understand the climate, hopefully on that bidecadal timescale that Goodwin was able to achieve in Polynesia, at least for some times in the Holocene. And this will involve compiling that proxy data and building a database all the way through the Holocene that is focused on that area, probably between like Port Hedland and Cape Range, but also takes into account the other regional effects. Some of that work is already done, a lot of it needs to be done. And then it will also include the proxies that we collect, hopefully, during this project. Not just myself, but other people who are building proxies during the project. And then it will be assimilating all of those into the most up-to-date climate models we can use, or the most appropriate ones. One of the things is going to be figuring out what specific method of data assimilation is the most useful to use in this situation, whether or not it's that best matching analog with a Kalman filter approach or some other version. And that will be done by testing them and seeing how they respond. And then lastly, comparing it with that like Murujuga archaeology, but also understanding it in the Australian context. Murujuga is interesting because it has a fairly seasonal climate. People are probably using that, but it sits kind of like, it sits on the boundary of different climate zones. So it lends an interesting perspective there. It's a recent archipelago in comparison to a lot of the ones in the Kimberley, which are themselves recent, but on the edge of a much deeper time scale. And is a really well-studied area, so it'll be interesting to see how that fits into the Australian context. Lastly, on admin, this bit will be quick, but I had to do it. Approvals and fieldwork, it's written my thing, but it's all kind of covered under the Dating Murujuga project. We've got the Reg 4, we've got all the other ethics, so that's all good. Now it's all good. The project timeline, this is kind of what it will end up being, is that I'd like to work on these papers. There will be some overlap. I'd say actually now, that Voyaging windows one like, will be started. It's already been started, really, that collection of proxies and kind of interpreting those. But this is like the writing up periods. But I think building towards that final Voyaging windows paper will be a concern, something that we need to time manage, because obviously data that's collected now with COVID and everything will take time to process and date and everything. So that's why I've got that laid out that way. And then just like a little bit of annual reports that I have to do and leave. And again, the budget is most of the work, all of the dating is coming through the Dating Murujuga's project budget. So my little fund that I get from the GRS just goes to like research and education and some training that I would like to do to upskill in climate science. So I'll bring it to a close by touching on the significance. I think we've already gone through a lot of the significance of this. So theoretically, it's important for archaeologists to understand the climate on a human scale. And that's a very, very, very tricky problem. It's one that will continue to be an open area of research. I just hope I can contribute in some small way to the methodology that people use and just the awareness of how tricky it is to deal with those uncertainties and to bridge the gap between huge processes that happen over thousands of years and to see how people will respond within their lifetime or within a particular few years. But specifically, maritime life in Murujuga it's different, it's unique, but it's also representative of maritime life anywhere, right? It's the same skills, it's the same problems that people are dealing with. And how do you traverse islands? Why do you traverse islands? So I think a lot of the things that we learn from Murujuga, in both how like climate can affect that, but also just why people do it from a cultural level, will be the same problems for which route did people take out of Africa? Was it like the southern route, which requires more maritime capability, or was it the northern route? Which way did people come to Malaysia and what time? What did that culture look like? Mixing with all that other work that's been done. So I think it's a contribution there. But lastly, I think it's also a contribution to understanding climate change today and in the near future. So I mentioned I have this image up to the side. that paper that's published this morning, because one of the co-authors of that on Twitter was like, well, what we are facing is in the low emissions pathway, which is here, is like a third of an ice age unit worth of climate change, if everything goes really, really well on the planet, which is very well might not. So that's a scale that we haven't dealt with in the historical record, but we have clearly dealt with in the archaeological record. The pace is much more rapid, but the magnitude is similar. And so hopefully there are some lessons to learn about that. This image is one of Tuvalu, in that they're like currently trying to understand whether or not they can remain a state if the island goes underwater. These are completely unprecedented legal questions, and ones that, like, as a society now, we don't have the social, political, and cultural frameworks for to deal with this catastrophic climate change. So I hope in some small way, by like pulling these out from the past on a human level, we can understand the possibilities to what our cultural and political and economic and social responses are going to be in the next kind of 100, 200 years within our lifetimes, and how that climate scale interacts with our human lives. So all of that, that's everything I have to say. Thank you very much.
Take some questions if there are any. So maybe I'll take some questions from the room first, and then if there is anyone online who wants to ask a question, just send a little chat message, please, so I can unmute you. Yeah, so is there a question from the room first? I'm curious to know if and how you're going to also integrate the Torres Strait Islands in your review of Australian islands and archipelago, because that's big.
It's huge, yes. Yeah. It certainly has to be considered, and it's not something that I'm familiar with. And so it's one of the reasons that it's clearly its own project. Yeah. Is that, yes, I will have to go through all the archaeology there and all the social work that's been done.
So you still want to include it in your review?
It has to be, yeah. The whole region has to be included. The focus will be, I think, around the continent itself, but I don't think it could be understood without including that. Yeah. I'm even interested, a lot of the thoughts that a lot of the theories and the ways that like science works in terms of islands has been formulated in Polynesia, obviously. So even that work, while it probably wouldn't be included in that review, is something that I've been going through, and want to keep going through. Yeah. Cool. Any other questions? Yeah.
So, Patrick, in terms of your review of islands, what proportion of islands do you think have had archaeological data for? Are we dealing with 5%, and was that representative, or are we dealing with much larger kind of regional assessment of the archaeological record on islands around Australia?
So there's about, like, Geoscience Australia has 5,000 islands listed for Australia, so there's certainly not 100% of those, I would say, have been done. But yes, there is a very particular set of islands that have also been done. But I'd like to, as far as possible, go through and find pretty much all of those papers that have been written. There are a lot of them, and that's why I think the review will take quite some time. But no, certainly most islands haven't been looked at. But the ones that are archaeologically interesting, I think people have selected those pretty carefully and have looked, especially a lot of the bigger islands, all in the Bass Strait and off the Kimberley and in Murujuga.
And you're part of the National Review of Island Occupation for a paper that's due in February.
That's good to know.
Do you have a question as well on this side?
Oh, look, I've got a couple. Thanks very much. That was really fascinating, and your idea of looking at variable maritime adaptations over not just current island configurations, but that much molecular stuff, how they emerge through time, I think is really clever. Because those cultural adaptations probably don't appear overnight. They're often looking at probably multi-generational patterns of offshore island use, which in Kimberley probably does go back 18 or 20,000 years or longer. I kind of caution comments like complex or difficult or challenging sea passage in the Kimberley. I mean, using tidal waters, crossing 6 nautical miles on one tide on a floating platform is not all that challenging. And that's why people do it so successfully and carefully through time. They're going offshore in the southwest, where 1 in 5 chance would be 25 knot wind or higher and probably fatality, trying a similar thing, are the differences of higher and lower energy regimes and the periodicity of those sort of regimes, and then the sort of cultural approaches which should fit. So that's where I think you've got an interesting philosophical issue around climate proxies and models. And you said to look through human lens, you have to do more than that. You have to use behavioural modelling and ecology. You have both of them sparking off each other.
I think that's one of the things I didn't have time to squish into this talk that I've been reading. I'm not tied to that idea, but I think it's really interesting. Dylan Gaffney with the idea of adaptive flexibility.
Yeah.
And so you have the idea is that when people go into a new climate, an environment, there will be a proliferation of the different technologies that people are using, the adaptations, and then people will specialise in some way over a particular period of time. But one of the, and he argued that is convincingly demonstrated in somewhere like Malaysia when people are clearly maritime adapted or capable, and then that is probably a reason people can get to settle. But said that there was an open question on the tempo of that, so whether or not people are adapting and throwing away things on a generational scale, which in Australia probably doesn't make any sense, or whether or not people are somewhere in the Kimberley, for example, would have thousands of years of increase in technology specialization, increased technology as the environment changed following the Ice Age in an island context, whereas somewhere like Murujuga probably only has 1 or 2 rounds of that right at the end of that change. And with such long cultural memories here, we would expect that there's something.
But I haven't seen those emergent island landscapes theorised in the way you're proposing to do for continental Australia. That's going to be really fascinating. Good luck with Australia.
There's a question here from Marianne Bailey, who says that it's a really interesting project, and she's wondering if there is any scope for sneaking in some isotope work, obviously for some scientific purpose, but also for you to come to listen.
Yes, Marianne is very patient with this. Look, I wish, to be honest, I wish I could get into the weeds of some of those isotopic proxy work, probably not. But there are many other people in our project who are doing work specifically with different isotopes and how they inform the climate record. I think it's slightly out of the scope of my project.
Yeah.
It would be nice if I get time and the funding. It's already cool.
Postdoc.
I have a question, Patrick. Yes. Especially when you start in building your momentum with PhD, you jump in on a paper which reviewed Holocene climate around Australia and islands. So Holocene is sustainable and it's 10,000 years. And it's actually quite reliable in different places in Australia. So I'm just wondering if you have maybe smaller kind of question. Would you be considered maybe breaking it into regions and intervals? Because it's quite a lot of effort.
Yes.
It's quite a lot of variable and sometimes not correlated data. So, it's kind of question, but it's also kind of for you to consider what this is a huge task to undertake at the beginning of your PhD.
I think the level that I'd like to get into on that continental scale is just an awareness of the amount of variability that there is. And that's why I think very quickly then in the second and third paper it zooms right into Murujuga. Because I think realistically, as you said, the only place I can hope to get down to that level of specifics is probably in one spot, if we can even do that. Which I think we probably can. So certainly those ideas and specifics that exactly what a human's responding to will only be developed for Murujuga itself. But I think it's important to have that background, yes, the intense variability in the Holocene climate, or where there are some lower levels of variability. Just what that looks like from that bird's eye continental view will be enough to get me to that next step of zooming into Murujuga.
Any other questions?
Got a quick one. Thanks very much for that sort of overarching kind of theoretical one around islands. Islands are very fascinating, and that makes them difficult to deal with because when you're studying them only, it doesn't tell us about the island and what people are doing. Doesn't tell us about the mainland, and doesn't tell us about some sort of relationship between the two. I think some of it sort of came out in the sort of discussion about looking at long-term places where islands kind of your backyard and we regularly go and from that and think of them so much as islands, landscapes such as yourself as you're doing there. But it's sort of like the Hobbits, right? So you have Hobbit on this island. It's all very fascinating, not quite sure what it illuminates about the wider picture. So I suppose in your significance, that would be one of the things to work on, to say, okay, so this study, what is it telling us about? Is it telling you that it's the islands? Maybe can you extrapolate from the islands to the mainland? Is it a relationship? Is it just the islands? Otherwise it might get a bit fuzzy, but and because it's a but say 3 papers, 3, yeah, more like 2 or 5, kind of thing. But it's just as people who write about islands often write about this is one that's great, but on what basis can you extrapolate from them?
That's really interesting, especially in a Murujuga context, in where a lot of you've got, definitely you haven't got islands that you're like voyaging over the horizon to get to, at least not in Murujuga itself, but you do have outer islands that people are interacting with very differently to the ones that are very close that you can probably relate to, and people probably are using those in much the same as you would use the mainland, except you do get a bit wet on the way. And whereas an island like Rosemary, it's a definite like behaviour to move out to. So it's yeah, as you said, it's a really nice spot to tease out these ideas.
Okay, there's a lot of congratulations on the Zoom side, and I think if we're done here, we're going to close it now. Thank you very much. Thank you, everybody.